So, a very good evening, everyone. I welcome you all for the day 5 of ATAL program, ATAL FDP on GIS and remote sensing applications in civil engineering for sustainable energy and climate management. I take this privilege to welcome you all for the day 5, session 9, and our speaker is Dr. Varun Singh, Associate Professor, Department of Civil Engineering, Motilal Nehru, National Institute of Technology, Allahabad. Before handing over this entire sessions to him, I would like to give a brief introduction of our esteemed speaker who has accepted our invitation to be the speaker of the session. Dr. Varun Singh sir is currently working as an associate professor in the Department of Civil Engineering, MNNIT Allahabad. Varun Singh sir has completed his PhD in the field of intelligent transportation system from IIT Roorkee. He has completed his master's in civil engineering with specialization in computer aided design from IIT Roorkee itself. He has he holds BTech degree in civil engineering from Aligarh Muslim University, Aligarh. Sir has guided so far 10 PhD, has supervised 10 PhD, and has also so many international and national journal in his credit. Sir is also the PI of many projects from amounting to rupees 1,68,000 to 10 lakh rupees. It is our privilege to have Sir as the esteemed guest for the session on energy efficiency and sustainable transportation with GIS. Now, without wasting time, I will invite Sir to speak on the topic. Please, Sir.
Okay. Okay. Thank you all, everyone, for organizers for giving me the opportunity to have some words over the energy efficiency and sustainable transportation with GIS. So let's start with my presentation. So this is the presentation outline. I'm going to cover some important aspects, uh, importance of energy efficiency and sustainable transportation. Next, what is GIS for transportation, energy efficiency strategies, and some case studies. And next, benefits, challenges, and future directions. And in the last, conclusions. And this talk will conclude with the question and answer sessions. And that is actually, you may ask some questions related to what we have done and what we can do further in the area of the GIS applications for energy conservation and some saving some like what we can say the improving the environment as such. So as you see from the geospatial data, so geospatial data comprises of we have the coordinates and the time and the feature. So as such, the transportation network comprises of the road network. So as in that case, we have the set of the road as a lines. Representation is being lines, and the intersection being represented like a nodes. So whatever you carry out the analysis, the road network forms the basis of that. Even other kind of the networks like rail network and air network also have the similar kind of the properties. So we have to define the linkage, and that linkage comes from the road segments, and road segments form the linkage. And whatever you are doing, the GIS is maybe the representation of the actuality. So for example, for the bus route, you may have the start point, end point, not exactly lying over the intersection. So, but the linkage can be modeled using the set of the lines, and the buses are running over those actually routes. So that is actually the important implications. Like whatever you are talking about the road network, rail network, they are represented somewhat differently in the GIS according to the simplification required for the analysis. So this is what I can say regarding the transportation networks. As such, as you see from the application of the GIS, that is the core is geospatial analysis. We have the number of applications in the different areas, And as such, we are using the programming environment and the GIS softwares for carrying out the spatial analysis. Spatial analysis that we are looking for have the number of important aspects like overlay analysis, pattern detection, proximity analysis, and buffering. So these are some basic analysis that you may have learned from the other eminent speakers. They provide you the glimpse about that. But we are all doing with our geospatial analysis. So somehow we are using these kind of analysis in the transportation networks also. And this is the general workflow. This is a very clear diagram that give the idea what we are doing in the case of the GIS. So I'm just without wasting too much time over there. So we have the raster data source, then the vector data source, and you are actually linking the attribute data with the vector data. And that linkage will give the complete form, the geospatial data. And that you later on use for the mapping analysis and some kind of the decision making. So this set of the steps are very important part of any GIS operation. And as you see, the geospatial technologies. So this lecture is more focused toward the application of the GIS, but there are some other complementary technologies like remote sensing, GPS, photogrammetry, LiDAR systems, unmanned aerial vehicles. So one of the application I will show later on where we have used the GPS dataset, and that dataset is visualized over the GIS. So we can get some important overview along the road networks. So that will I'm going to discuss in subsequent slides. And when you talk about the GIST, so GIST is actually the Geographical Information System uh, for the transportation. Yes. Actually, I get somewhat. Should I share once again my slides because that is actually get.
No problem, sir.
Okay, okay. Now it has been like that. So because number of windows are opening side by side where I might see myself. So that has been there. So GIST for the transportation is the application of geographical information systems, especially for solving transportation related problems. So one of the problem is routing. What you have seen already, you are doing day by day. Like you are using the Google Maps application or navigation map application in your Android phone. There you are finding out the possible route of the travel. So this is the basic application that is being like at the provided at the end user. So this is one of the problem like that you are solving using the GIS is being provided by the Google. So you want to find out the possible best quickest route or shortest route of the travel from your location to some destination location. So this is one of the application. Other applications like if you talk about the applications of the GIS, that is transportation planning, traffic visualization, and some other applications where we want to know the find out the suitable position of certain like businesses and all. So that is also being required to be carried out. And one important application is like waste collection. So waste collection vehicles are being collecting the waste at the different locations. So we are going to use some kind of the GIS to have the planning for the like transporting the waste from one location to other using the vehicles on certain routes that are optimized. So that problem is known as the vehicle routing problem. There I will going to just explain one of the case study related to that one also. So GIST integrates spatial and transportation data to analyze, manage, and visualize transportation networks and infrastructure. So what type of the transportation data we are looking for? Like we are talking about the traffic volumes, travel times, and travel speeds. So that is kind of the transportation data. Spatial data is the road network or any other transportation network. So combining, we are getting some kind of the GIST data set and we are using for the different purposes. So key transportation components of GIST like transportation network modeling. mapping and analysis of the roads, railways, waterways, and airways. Spatial analysis that you carry out, that I have already explained. Data integration. So you are combining the geospatial data with the transportation specific data that already discussed, like traffic volume is the number of vehicles in terms of the PCU per hour in the given direction, and vehicle types and infrastructure and the traffic speed and other traffic density in some of the cases. Those form the transportation related data. And decision support is been also been supported by assisted in planning, monitoring, and managing transportation systems. So these are the decision support that can be provided by the GIS when you are combining with the transportation data. Now, one of the applications that I have already discussed is route optimization, but we are going in much more depth, like considering the other aspects like electrical vehicles. GIS can account for topography, battery health to plan the energy optimal routes, thereby extending the driving range and preserving the battery life. So, like this is the one of the application that we can use with the electric vehicles and other types of the vehicles. So green transportation, what we are looking from the GIS to do the planning of the routes based on the topography and other important aspects related to the vehicles. So that can be combined together. And the research is already been happening in this direction to find out the possible routes of the travel using the considering the very detailed GIS data set. So this is the one of the aspect, like you start with the workflow. So I have taken this from the research paper, that is energy efficient route planning for electric vehicles with a special consideration of topography and battery lifetime. So that is combining the number of aspects, and we are able to start with defining the location of start and destination location. Then you have the road network data set is being used, and next come out to be the vehicle parameters and calculate energy consumption and journey time for all road sections and define constraints and weights for the multi-objective optimization. So somewhat we are using some more advanced parameters to carry out the multi-objective optimization considering the different constraints and finding out the best possible routes of the travel using the algorithm that they have used, like Yen algorithm. So this is the specialized algorithm for the route finding. So this will provide you the better understanding about the type of the parameters used in this study. So define start and destination points, gather road network data, including topography, land, slope, altitude difference. So slope is very important aspect, and we are getting the elevation value included into the analysis. So already we are using the X and Y, mostly the latitude, longitude values or any coordinates reference values. Like if you are using some projected coordinate system like UTM, Universal Transverse Mercator projection system, there we are talking in terms of the X and Y values that have the long values. Like so, next is we are considering like for example the other aspects like slope. So that we are considering the elevation values, like to get the values of the slopes and altitude difference. So these are all considered as a part of the analysis. And next is the to calculate energy consumption using the physical forces and efficiencies. So we are using some energy consumption model, like that is considering the regenerative braking. So these aspects are considered. So they are a specialized technique for the where the braking energy is being utilized again for the vehicles. So that is called the regenerative braking. And next is the SOC. So SOC is actually the capacity ratio of the current energy stored in the battery to the total energy capacity of the battery. So these aspects are considered, and the calculation is happening on the basis of that. So I think these are aspects for the route planning that you can do using the GIS while considering the number of factors. And the reported visualization can be in forms of the map. So you can have the results available in form of the map. So in that map, we have the routes being defined for the different origin and destination location. So these aspects are considered as a part of the analysis while you are considering the GIS. and other factors being the part of the analysis. So next application is traffic flow management. So you can combine the real-time traffic data, GIS, other data in monitoring and managing traffic congestion. So analyzing traffic patterns allows for the optimization of the traffic signal timings and the implementation of dynamic routing strategies. So in this case, we are considering the real-time traffic to understand the movement of the people from one location to other using the routing strategies. So these routing strategies can be implemented and we can have the better traffic flows. So in that case, traffic signaling timing and visualization can help in the better way to understand the traffic flow. So I will discuss one of the application that we have carried out. This is not only enhance energy efficiency but also decrease the overall travel time. As you see, when we are being stopped at the intersection location, so vehicle is continuously running. So 2 to 5 liters around of the fuel is being as per the different studies that is been actually been considered, and those fuel consumption happens, and that fuel consumption, if you add up together for number of vehicles, that add up too much energy usage. So in that case, we may have the using the smart signaling system, we can optimize the signal timing, and that will reduce the waiting time for the vehicles at the stop lines at the intersection, signal intersection. So this is one of the important aspect. So next is important aspect is electric vehicle infrastructure planning. So GIS is instrumental in finding out the possible optimal locations of the EV charging station. So this is the next application that can we have using the GIS. So by analyzing factors such as current and projected EV usage, traffic patterns, and proximity to the power source, GIS ensures that charging infrastructure is optimally located. So charging stations, if the EVs usage are increasing, so how to just locate the charging stations? This is the next important aspect is being coming up in the recent time. So next application is doing something like that. So this way we have done kind of the study in Prayagraj, and I put it the my resource of the my publication. So this is what we have done using the we have used the Pro Vehicle. So Pro Vehicle comprises of the we can have the number of sensors installed in the Pro Vehicle. So we have made some hardware that comprises of the accelerometer and GPS receiver, and combinedly we are getting the data. And next is we are use the ultrasonic sensors to understand the vehicle to vehicle distances. After doing some this kind of the data we have, and we are using some kind of the analysis, from there we are, can map that data and find out the locations where we can have the more congestion happening. So as you see, certain red locations are the location where we have the more congestion on the basis of the speed data and the vehicle to vehicle distance. So that can we can combine together like GPS. From the GPS data we are getting the position of the vehicle, and the vehicle is moving in certain road sections, and from the GPS locations with the time we are can get the speed values, and from that speed values and vehicle to vehicle distance we can calculate the locations where, or we can find out that locations where we have the more congestion. So this kind of the analysis we can do and visualize using the GIS. And the map is being shown here on the right side on my screen. So again, one important aspect, we have used the other like dash camera to know the traffic scene in front of the vehicles. So we can validate our analysis with the actual condition on the road section. So this what we have done using the GPS, GIS, and sensor technology. So this is a very important application that is being used in the recent time also in the autonomous vehicles, that is also sensing the nearby road sections and the vehicles, and through which these autonomous vehicles can take the decision like how to decrease or increase the speed on the basis of the distance of the front vehicle. So this is one of the application that we have done. Next application is what we have seen already, electric vehicle infrastructure planning. So GIS-based site selection model can be developed for optimizing urban investment in the, with a specific emphasis on the locating electric vehicle charging stations. So GIS model can be developed that integrates the different criteria categorized into the environment and geographical factors like vegetation, proximity, topography, economical consideration, proximity to the commercial areas, urban characteristics. So this study is, I will show some visualization of the maps, like through which we can consider the number of criteria and find out the optimal locations where we can have the charging station. So utilizing multi-criteria decision making, where we are giving the weights to the different cases like proximity to the particular locations or nearby location should be within that like certain range. So these aspects are considered and multi-criteria decision making is being applied. And finally, we are getting the outcome in forms of the locations where we can have the charging stations being possible. So this study has been type of the study being reported in Turkey, like Pendik in Istanbul. So here we can see that number of consideration is being met, like distance to the landside risk areas, slope of the land, possibility of the exponential earthquake risk, and other possible aspects. So these aspects are considered, and these aspects are important to understand, like to find out that location where we can have the charging station. So you give the multiple weightage to the different type of the consideration like distance to the vegetation, water resources, and all, and find out the optimal location where we can have the charging station possible. So as per their research, the authors has been reported these kind of the maps. So we can find out that locations where we can just build up the charging station. So these are the certain kind of the research or direction that is happening using the GIS. So next, I will go further with the case studies. So one case study is related to like public transport accessibility in SCT Delhi, National Capital Territory Delhi. So that we have carried out using the like find out the accessibility to the um, bus station and metro stations, like how much walkable distance is required to reach the metro station or bus station. So comparative analysis we have carried out. So as such, the accessibility is defined ease of reaching opportunities like goods, services, and destinations. So that is the measure of user effort in accessing the public transportation. So this is a very important and interesting actually like effort that we have made, and find out those areas where we have the less accessibility, walking accessibility we are talking about, not accessibility by personalized vehicle, but accessibility to the nearby metro stations and the bus stations. So that we have carried out that kind of the analysis. And factors is that is affecting the accessibility number of vehicles per hour, transport travel speed, and other factors. So one important aspect I can brief out here from here, like buses frequencies are changing throughout the day, as well as the metro rail ability is changing throughout the day. So we have carried out the accessibility in terms of like how that accessibility is varying throughout the day to the different modes of the transport as well as the bus stations. So we have first studied the walking accessibility, next accessibility with a set of origin and destination locations using the real-time data set, like day-wise the services are changing. So we try to map and try to understand that how that variation happens throughout the day. Like facilities are being fixed, like bus routes are being fixed. So, but whatever been the frequency of the buses are being the important aspect. Like buses are coming at the certain locations at the different intervals. So we have to see out how that accessibility is changing for the given set of the origin and destination location. That we have studied as a part of our effort. Now, gap covered in this study that we have seen, like most study do not consider the temporal variations in the accessibility due to the change in the traffic conditions or public transit schedules that I've already discussed limited use of tools like Google Directions API. So we have used important functionality of the Google Direction API. So APIs are application programming interface or the functions that helps to just find out the how much travel time or travel distance is being required from origin to the destination locations and other much more details like how many stops you have to just been there between the origin and destination locations means the bus stops and the metro stops. So that all information is being we can fetch using the Google Direction API. Walking accessibility has not been extensively analyzed for diverse land uses types across the national capital territory region in Delhi. So integration of walking and public transit accessibility and unexplored. So we have carried out this using the GIS and other advanced tools from the programming. Like we have used the Pandana and Urban Access uh, specialized libraries, and those libraries are being used for the analysis. So next go further. And these are the actually tools and libraries that has been used for the our analysis. And these are the Python packages, you can say, or libraries that is useful to carry out the spatial analysis as a part of GIS. So as you see from the like from these tools, so you can do the network analysis. Some like GIS software that we have used is the QGIS. So for the geospatial data processing, visualization, format conversion. So we have used the multiple types of the tools and techniques to do our analysis. And Google Direction API we have used for the real-time transit data for the origin destination pairs that I have already discussed. So the data where we can get the data. So we have digitize the data as a stop locations on the metro. So this is for the metro network. So their MRTS, mass rapid transit network. So this is the proper way we can define the metro network. But in that case, you have used and the geo positioning or geocode the data about the positions of the metro station. So that data we have considered for the analysis using the Google Images as well as from the road network or metro network from the that is available and published on from the website MRTS Dell website. So next, what we have used for the our analysis is the static data. Like we have used the data from the what we are calling the GTFS data. So this is the bus data, and that data is also been published for the Delhi. So here we have the number of information we can have here, like stops, routes, stop times, and trips. So trips are being made over the certain set of the routes. Stop times are the time at which the buses are arriving and departing from the particular stops. And stops are geo coded information about the stop locations. So these set of the data forms the what we are calling as the GTFS, General Transit Feed Specification. So this is the important data set in the public transportation. And here we have used the static data. Unfortunately, we don't have the real-time data available for our country. But in other countries, they are also providing the real-time data set regarding the arrival of the buses in the real time. So these data may have the better possibility regarding the analysis. So this is the important aspect of the these kind of the data set. Now, as you see, the type of the data set we are talking about. So we have the number of files available as a flat files, and those files comprises of the these information like as you see from the this chart, and that provide the number of information being stored and saved. You can use that one for the analysis. So we have used the routes and trips data set for an urban access package, Python package we have used to convert into the GIS readable data. So that we have used like bus stop location is being done like that. So these are being extracted and we have carried out the analysis over there. And this is the workflow that we have applied like for the analysis. for starting with our transit data preparation. Now, next is the walkable network. So we have used the data set like road network as well as the transit network. So these are two important aspects we have taken care into the consideration. What happens road network is different from the transit network because of the consideration buses move on in certain direction and following the certain road segments, and we have created the both of the data set and combining them together for the analysis. Like Open Street Map data set, this is the free data set that you can use for the analysis. So like this is the road network data. From there we have extracted the road network data, and other data transit station data set is already been, we have extracted from the other processes like GTFS and the geocoding the data about the metro station. And next we have calculated the accessibility matrices, compute walk time to the nearest station, metro and buses. Consider the walking speed and the slopes of the road sections, and calculate service area coverage like within the 5, 10, 15 minutes walk, how many bus stations or metro stations are available. From there, we have carried out the analysis and identify areas with a limited transit access. And we can visualize this data using the map. So we have programmatically generated the maps also using the Python codes. So, and as you see from this workflow, so how the been applied for the walking accessibility analysis. So, but we have considered the nearest stop from the different locations. So we have divided the complete NCT into the small parts according to the what the world, and that world is divided again to the small set of the grids, and that grids are have certain centroid. From those centroids we have calculated the nearest bus stop or metro stations, and after that we are getting some kind of the analysis being there. So we see out what we have created the uh, chloropath maps, and that shows the color coded information regarding the walking accessibility. So for the different locations, we can see out certain areas have the more walking accessibility. So we have the less value means more accessible. Large value of the walking time is been there. So that area is more less accessible. So outer areas of NCT Delhi are not much accessible in comparison to the central Delhi. So this is what we have observed from the analysis. So this is this kind of the analysis can help to design and make the public transportation more accessible to the users. So in that way, we can have the better planning possible in terms of the uh, metro stations and bus stations. So as you see, the accessibility to metro stations are being lesser in comparison to the bus station. So because the bus network is comparatively larger. So that's why this is the reason. If you talk about the class B cities, like other cities, so we have the less rideability of the metro rails. So this is what is the major point of the contention, because the accessibility is less. If the accessibility is provided better, so anyone can access the metro net facility. So this is important aspect. Like accessibility is, if you don't have the better accessibility, the metro usage is not very much in use. So this is what we can see now. Now next, we have done with the land use type. So as you see, the industrial areas have the lesser and lesser accessibility to the both metro as well as the bus transportation. Similarly, we have done the analysis for the residential areas. So these analysis can provide you the better understanding of the public transportation coverage and usage. So next is commercial areas, and also we have done for the other recreational and areas also. So these analysis can give you some certain idea. And as you see, talk about what is the average accessibility in terms of the minutes. We can have this flow chart, bar chart being generated, and that bar chart can give the variation in terms of the accessibility, which area have the better accessibility in terms of the travel time, which areas are the lesser one. So, and that will give the certain, you can say, idea about the land use types that needs to be have made more accessible to the public transportation. So that you can do using the analysis. Next, what we have done using the goal direction application programming interface. So we have selected certain locations and we find out how that accessibility varying throughout the day. So this you can also do using the Google Direction API. So this is just a application like GIS application. So as you see out, like we have selected certain set of the data. So this data is being generated like origin, destination, route ID, timestamp at which you are uh, seeking the data, the distance, travel time, departure time, and arrival time. So how much time is being required to travel. So all these information is been we have fetched, and the fare number of fare in some cases where the fare information is available, and number of stops between the origin and destination, and walking distance, how much you have to walk to the to the nearest bus station or metro station, and how much walking duration you have. So this has been there. And next is the geometry of the route, so that you can generate the data set. And we have used this kind of the query you have to make like from location, like origin location and destination location, and departure time, at what time you want to know the these information. So that is been like that. So if you are doing in the real time, you will have to set the departure time now. And mode is transit. So the it can be the like bus or metros. So that you can have, and you have to provide some a key. So that key is actually the key to validate you as a user. And after that, you can get the information about the different these information that we have seen on the left side. So that tabular data we can have. And these set of the locations we have selected like for the analysis like IGI airport and other market areas. So the justification is been also been put it on the right side like remarks. So why we have selected those areas. So that those actually selection we have made. And like tips, we have considered the 10 tips for our analysis, and origin and destination tips are being we have. And on the basis of these trips, we can find out that how much time of the travel is being there and all the information being fetched. And these is the flow chart through which we can process the data regarding the finding out whatever we data we require for the analysis. So this is been there. So I'm not reading out, but you have to see out the way we can do using the Google Direction APIs. So you have to construct the API URL that we have already seen, like web link. URL means the web link, and you have to just send that request to the Google servers, and they can provide the data. So that so this data can be we have after the data we are getting the data in certain other forms. So the what we are calling the some coded form, and that data is converted into the table form from the programming, and we can have the number of information being fetched, and we can do certain analysis on the basis of that. So like for example, for the different trips, what is the average travel time in seconds? So we can know the pairwise accessibility to the public transportation, and average. Then we can have the other analysis possible, like for the different times, what is the average travel time for all the trips with the time variations. Like so, this time is nothing but the time of the travel. At what time you want to travel. So for the different times, we have getting the different average time of the travel. So this kind of the analysis you can get from the data that we have extracted from the Google Directions API. So this is certain remarks I put it like that. So bus journey often longer than the metro trips due to the bus making additional stops, encountering the traffic. Metro trip 2 is quickest of all metro travel. So comparative analysis, you can go through the from this kind of the data set and find out how the accessibility is varying from location to location. An important location you can select and carry out the analysis over there, that one also. So walking distance, you can have like understanding like how much walking is being required to move from one location to other. So I want to put here the important point, like whatever the actually the variations happen is due to the change of the bus route. Like buses are being considered while on the basis of the optimal timing of the travel. Like what happens at the morning time, you have the different service. In the evening time, you are using the different service from the same pair of the origin and destination, because at the particular time, one service is better than the other. So that's why you are getting the difference in the travel time also. Otherwise, average the static data we have, from that static data, the variation is not that much visible if you are considering the same service. But if you have the different service available at the different time of the day, you may have the different travel time and walking distance all comes out to be different. So this is the analysis that you can go from this analysis. So you can have the fare information available for how the fare is varying throughout the day on the basis of the analysis. So sometimes you have the more fare than the other time. So this can be possibly done. So next case study that we have done is also an important study. I will brief out this very important study here also. So we have considered certain waste collection locations and dumping sites. And what we have considered in this analysis is the AQI, air quality index. So we want to avoid those locations where we have the AQI values be more. And this is a somewhat very challenging to get in the real time. So we have solved what we are calling as the vehicle routing problem. So vehicle routing problem is what I will discuss in a very simplified manner. They are set of the vehicles, and there's a depot locations, and from those depot locations, the vehicle will start and serve the different locations, like what is called the customers or service locations, and come back to the depots. If you have the multiple vehicles available, and you want to design and plan the routes for the those vehicles, and vehicles have certain set of capacity, and overall you want to optimize the uh, transportation cost in terms of the travel time and waiting time. So this problem carries some certain meaning. So here we need to know the point to point travel time in the real time. Sorry, and other information like which road segment is one way and other information. So that kind of the important aspect is there, and also the vehicles have certain set of the capacity. So we want to optimize the overall operation of the trans transportation or the service that we want to provide. So this we have done using the GIS application. Again, we have used the different services, what is called the hair maps. And because Google cannot provide you the route that you don't want to take. So in that case, it always shows that those locations, those routes that is optimal in terms of the nearly on the basis of the traffic and other conditions. But if you want to find the route while you want to avoid certain locations, that is not possible. So in that case, what we have done, we have used certain API again, that is from the hair maps, and found just try to find out what is the optimal route of the travel while avoiding those locations where we have the more AQI values. Those locations, like certain areas have the more AQI value during, even in this winter times, we have the very high AQI value. So we have considered the criterias like those locations are filtered out from our analysis where the AQI value is exceeding 200. So that analysis we have carried out. So um, these are the service locations where we have considered the 40 service location and 4 dumping sites. And these locations are considered. And as you see from this analysis, we find out certain locations where the AQI value is more. And from that analysis, we just filter out those road network sections that we don't want to traverse. From this analysis can provide you better understanding to avoiding those sections where we have the higher AQI values. So the analysis will be carried out while not considering these areas. So that you can also do using the GIS and other analysis. So the data has been considered, and that data is we try to just take into the consideration while avoiding those areas. And like these are the certain locations. Those locations we have considered, and those locations are the locations where we have the air quality monitoring stations. So around those stations, we want to find out those road segments where we don't want to travel. So vehicle routing happens or planning happens while considering the other road segments. So this is been considered as a part of the analysis. So this is the flow chart. So I'm not coming to this flow chart, but I want to make it clear. Like we want to now in that vehicle routing problem, we have to generate the OD matrices. So OD matrices we have generated using the real time data. At what time, like peak hour times, we have carried out the analysis where the traffic is maximum, like from 9 to 10. So certain time we have selected and find out the in the real time the travel time between the origin and destination location. So origin is the destination locations are nothing but the inter these service locations. So those service stations are being considered as a part of the analysis. So like so this is the optimization function. So I'm not going to the detail, but we have to optimize the overall time distance of the travel and other important aspects like. So one important assignment that we have done because uh, dumping sites are being fixed and you have to cluster the set of the service stations according to their proximity or nearness to the dumping sites. So for that, we have carried out certain analysis using the what we are calling advanced algorithm. We have used what is called the genetic algorithm, non-sorting genetic algorithm. Second, so from there we have divided the service locations according to their territory and fixed the conditions like that. So particular dumping sites are serving set of the locations. So that we have done as a part of our analysis. So assignments happen. As you see the different locations. So here we have considered the dumping sites locations like Okla, Gazipur, and Balsaba. So these are the locations that we have considered as a part of the analysis. So after doing the this consideration, we can generate the optimal route of the like travel while avoiding certain locations. So this we can do from the uh, uh, libraries like known as the OR tools that provide the vehicle routing functionality to do the vehicle routing over the spatial data. So that is we have done. So we can have the like this kind of the possible planning that can be generated, how much time the service is required, how much time is going to be traveled. So different vehicles start at the different locations and come back to the same location, so that you can do using uh, the geospatial dataset or GIS dataset. So next study that has been it is a brief one. So that we can carry out using the like for this is Copenhagen is the like capital city of the Denmark. They have used the GIS to optimize routes, manage traffic, and integrate green infrastructure. So what they want to have the vision like that. So they want to make their route network bicycle friendly. So that they have used the GIS for that analysis to improve the movement of the people using the bicycles and reduce the dependency over the personalized mode of the transportation. So there they have used the GIS. And as you see, what we can get from the benefits like using the GIS for the spatial analysis, especially for the transportation application. So where it can be used for the route optimization and generating the energy efficient routes and improve the public transportation, so we can have the better accessibility possible while we can identify those locations we have the less accessibility, and traffic congestion can be reduced by understanding the locations where we have the more traffic and doing the traffic analysis and combining and with the GIS to visualize the locations where we have the more traffic. And environmental monitoring can be possible, so you can have the what we are calling as the air quality maps and the noise maps, where we can generate the maps showing the different air quality and noise levels. So that can also be used for the environmental monitoring. And next is the real-time management uses real-time data for the traffic flow adjustment and energy saving. So that you can use the data that can be visualized over the maps and finding out those locations where we have the more congestion. So some adjustment, like one of the adjustment or the measure that you can take in this direction is known as the congestion pricing. Like what when the vehicles are moving in the during the peak hours, so those vehicles are being charged some money. Like you have the fine being imposed over the over speeding, other traffic violations. So similar, you can go for the congestion pricing. So in that case, what will happen? The vehicles they are entering during the peak hours in certain central business districts or commercial areas. They have to pay certain amount of the charge. So or what we are calling the electronic pricing also. So this we can also do using the GIS. While identifying those locations, we have the more congestion been there. So this next is the cost efficiency, optimize resource allocation, and reduce the operation cost while considering the actual movement of the vehicles. So in that case, we have seen like charging station locations, an optimal route of the travel for the EVs. So that can be designed with considering the GIS data set. So this can be possibly done in a good way. And challenges, the major challenges are like the data, like data should be updated. Like if you are the new development that is actually being shared, and we need integrated data for diverse sources with varying formats and standards. This is the other important aspect. Like data is actually available in the different formats. So that is the basic challenge to do the analysis using the GIS data set. Some are available like in one format like AutoCAD format, and some is available in other format like shapefile format. So you have to combine all data together in the different formats that is available in the different formats. So this is the major aspect, like data integration is a major problem that happens in the real times. And as you see, the municipality is maintaining the data mostly in the AutoCAD drawings. So, but the GIS required the geospatial referencing of the data. So you have to convert that data into the geospatial format. Again, you need some kind of the processing. So next is the cost challenges. High initial investment in the GIS technology and infrastructure. Now this is reducing. What I must say, like we have used the cloud services like Google Maps and Here Maps. From there, we can understand like certain data set is being available uh, in remote locations as a cloud services, and from that data we can do the analysis. So this is important aspects, like more or more applications I have seen using the Google Direction APIs, Google Maps API, and also these other services like Here Maps. So from there we can save the investment in the creation of the data. That is the burden of the company that is maintaining the data. So we can have the better possibility of the using the GIS tools when we are combining these services with our analysis. So that is the important aspect. Integration challenges, system compatibility, and interdepartmental collaborations. So this is the like one way people talk in the different ways. So one organization is doing in a different way the GIS, other is doing different ways. So integration and compatibility is other important aspect regarding the GIS. So, but we need the interdepartmental collaboration to have the successful GIS possible in the case of the transportation sector. And future direction. So as you see, move toward the more complex analysis using the GIS. So AI analysis, artificial intelligence, and machine learning is becoming an important aspect in the analysis. So, like they are being now being frequently used to forecast the traffic patterns and optimize routing and automation, implementing autonomous systems for the data collection and analysis. So, like example, what we have used here, the Google Direction APIs. And sustainable planning and policy development is again other effort, like incorporating renewable energy sources and green infrastructure in the transportation planning, and policy development supporting the creation of the policy aim as reducing the carbon footprints. So one of the applications that I've shown, like doing the vehicle routing using the optimal routes, while we are avoiding those areas where we have the higher AQI value, air quality index. So that we can do as a makes as a planning process. So green, what the term is coming in this direction is the green logistics. So avoiding the usage of the more and more energy and saving our time. So this is one of the aspect regarding that decarbonization. So GIS can be helpful in this direction also. And multimodal planning, while we are combining the different modes of the transportation to avoid the dependency over the personalized vehicle transportation, because personalized vehicle transportation is causing a lot of congestion and other traffic related problems and increasing the energy levels. So that is actually being required to be reduced. So we, as you see from the different efforts, we can go for the planning of those aspects, like multimodal planning can be possible. So you can combine the different modes of the transportation, like bus transportation and metro transportation, like MRTS transportation, to get the overview of the planning possible. And accessibility analysis, ensuring equitable access to the transportation options for the all the population, that we seen from our analysis, like disparity in terms of the accessibility to the public transportation in the different areas. So we can see out where we need to improve. And as you see the conclusion, so we have the emphasize over the potential of the GIS technology, where that can be integrated with the emerging technologies to create a sustainable and efficient transportation system. As you see from the different like case study that I presented here. And we need to call to action for continuous investment in the GIS and collaboration among the different stakeholders to overcome challenges and harness future opportunities. So these are certain conclusions that I want to put it here also. And finally, as you see, sustainable transportation and GIS in action and future trends are going hand by hand. And as you see, the more and more GIS application coming in the future also in more aspects. And thank you all for the patience hearing and for your time and interest.
Session is open for question and answer. If you have any question, you can just put up in the chat box. I have allowed you all to unmute. You can, sir. There is one question actually.
Okay, okay. Yes. What are the challenges in large scale implementation of EVs in developing countries? How GIS can technology can address these challenges? A good question it is. So actually, what happens in the current times, EVs are actually being discouraged in other countries in these recent times because of the battery disposal problem. So we are going for the hybrid systems also. But now this is better than the fossil fuel type of vehicle ignition engine that we have seen using the fossil fuels. So in that case, we can have the like if you want to go for the large scale planning and implementation, you need the number of data set. For example, land use data set, the traffic data set, and variation. So that data is comparatively lagging in our country. So one example, like we don't have the data set about the proper road network data set. So I've used the one of the service from the Open Street Map. It is an open data set service for which we have extract the road network data from any part of the world. So we have used one of the package known as the OSMNX. So that package can provide you the information about the road network. So this is a good question in that case. The basic challenge comes from the data. If we don't have the good data set, we cannot do the good planning. And that is a major aspect in long time. We are when I start working in this area of the GIS, still we are finding that much of the problem. In other countries have the good data set about the road network and other. Google can provide you the information. For example, one example I want to put it here, a good example, like Google can help you to find out the optimal route of the travel, but it cannot help you to find out where the maintenance work of the road section is going on. So in other countries, they have the good services. They are getting the real time data, and that is on the basis of which we can have the like data being visualized, and user can do the number of analysis on the basis of that data. Like, and that data is missing from the Googles. So today's I'm teaching to my students. I'm teaching a subject intelligent transport systems. So that in that case, we are talking about how the Google can replace the other travel information services. Answer is no, because they are not providing the real time data. And to carry out the real time data set as a planning part, you need a data set for the number of years. And one of the effort that I have not shown here in this like presentation, but we have used the Uber movements data. That data is been available around the world, and recently they have taken down that data set. That data provide the how much time the taxis are taking from one location to other location, from one zone to other zone. So that data we have also analyzed for certain analysis for predicting the time of the travel from one location to other. So Uber moments provide a good way to understand the like how the data is varying, like travel time is varying throughout the day or say months. So as you see that these kind of the data set are basically very much required. Land use data set, transport network data set, real-time traffic data set, and other information. Not only the this data set, the one-way lane data set, how much road sections are being type of the road sections, whether it's a divided highway, whether it's an undivided highways, how many lanes of the roads have. So these all are the important consideration. And EV's characteristics. EV technologies are improving in terms of the battery types. So battery is the major problem. Whatever the major research is going on, the long life of the batteries. So while considering these aspects like improvement in the technologies and the data set, that requires a lot of effort to have the EVs planning. But we are, as you see, we are lagging in terms of the data set. So this has been one of the case. So number of questions are coming as you see. So it is possible to assess dynamic change in the air quality data. This is true. There are certain application programming interface through which we can understand the how much the change is happening in terms of the air quality index. So this application, what we have used a certain kind of the real-time API, and I'm not able to show here the link. But in any case, if you want, if you want, you can send me the some request to. I will provide you the link through which we can get the real-time data set about the AQI values in certain areas. So that AQI we have used for the analysis. What happens? The data is required in the real time when you are planning like how which route the particular trucks should take, or garbage collection trucks, what I'm talking about. So they need the data about the which area have the more AQI. So they want to avoid those routes having the more AQI. So this kind of the data set you can get from the real time application API. That is also a kind of the API through which you can do the data, but you have to process it for your analysis. You need some programming skills to use it, because they give the data in certain what we are calling as the JSON format, other XML format. So that data is not readable in tabular form. So you have to process that data to make it readable. Again, you have to use that readable data for the analysis. So what we have done like that. So the analysis is not so easy that way. We have used a number of ways to process the data to get the particular direction. So this is the question that I think, sir, can we combine the road network of the rural areas, also access to the hilly areas using the GIS? Yes, you can do also, but the major challenge is again the data set. In the hilly areas, again we have the less mapping of the road network. So complete mapping is required in that way. So and also in the rural areas, can we combine the road network of the rural areas? This can be possible in a certain sense, but city wise we are doing mostly in the city wise. But for the rural areas, we need the more refined data set, because complete mapping is not available in all other areas. More majorly in our country, the mapping is available in the form of the road network is mapped, and that data is available as an open street map data set, and through which you can get the data. But other areas, I cannot guarantee that each and every location is mapped completely from the open street map data set. So this is my answer. So basically, the major problem is only the data. The analysis can be the comes to the next, but we have the lesser data possible. So next question is been there. Uh, sir, any other question? Okay, EVs that I have answered like that. Any other question from the audience?
Thank you, sir. I hope there is no question right now. It was
Hmm.
an amazing session, sir. So informative
Hmm.
session. I can see the feedback in the chat box only. So thank you for accepting our invitation and
Hmm.
making into reality. It was a nice session from your end, and I
Hmm.
hope to join you more sessions for incoming future. And
Hmm.
thank you so much once again from the bottom of my heart on the behalf of Buddha Institute of Technology and on the behalf of organizing team. Thank you, sir. Thank you
Okay,
so much.
thank you. Thank you. Okay.
So once again, a very good evening to one and all. So this will be the session 10 of day 5. And our esteemed speaker is Dr. Hari Narayan Tiwari, sir, co-founder FloodCon Consultant Limited and advisor Pandit Software Solutions Private Limited. Before handing over this session to Dr. Hari Narayan Tiwari sir, I would like to give a brief introduction about him. Dr. Hari Narayan Tiwari sir is the co-founder of FloodCon Consultant. Dr. Tiwari is the initiator of two diverse programs, SOCH for Children Behavioral Change About Water and FloodCon Practice Program for Young Minds to Make Industry Ready from FloodCon. Dr. Tiwari is the alumni of BIT Sindri and IIT Roorkee. He was the recipient of four district awards, including gold medalist at IIT Roorkee. Dr. Tiwari has to his credit 13 years of research and professional experience in water resource engineering with a focus on river engineering, flood and drought management using remote sensing and GIS, hydraulic structures, irrigation planning and project planning. Dr. Tiwari has also served as consultant at Ministry of Jal Shakti, Government of India. Dr. Tiwari has worked over 93 prime consultancy projects. In his credit, over 50 national, international levels of research papers. Dr. Tiwari has delivered several invited lectures on different aspects of water management at different stages. He has also started a magazine, Pani Teri Kahani, for 360-degree views about water. He has also started online training under company Professional Education Responsibility (CPR) and provided the professional training to around 100,000 plus young engineering students at no cost. It is our privilege and it is our privilege to have Dr. Tiwari sir for this session. Now, without wasting my time, I would like to invite Dr. Hari Narayan Tiwari sir, and I will hand over this session to him for the next session. Please, sir.
Thank you, Ankur, for introduction. So I would like to start. First, I will share my screen. If is it visible, please mention me. I think the screen is visible. So as
Yes,
we
sir,
are
it is
sitting,
visible. It is
yeah.
visible.
Good evening, everyone. Who has participated, and thank you, Ankur, specifically for this particular session. So actually, I'm just talking about the uses of remote sensing in different aspects of water resource management. Because all of you know that now it is a era of remote sensing, because lots of data is coming through the satellites, drones, and others equipments without touching. Because remote sensing is not only that, that means we are taking a data from a satellite. So that is not only remote sensing data for a water resource. So we are discussing a small segments. Maybe you are also aware about that. So, but in industry, what is the practices and what we are doing actually when we are doing practical projects apart from the academics or curricular activities. So first, you all of you, because you belong to the civil engineering or somehow related to the remote sensing background. So it is a simply to acquire the information without touching the object. So that is the remote sensing. Suppose our eye is, you can also term it as a remote sensor. So we can sense lots of things without touching anything. That means if the color is red, if the color is so, eye is, you can say, first remote sensing or natural remote sensing equipments. So that's only possible due to the transaction of energy. So it is a simple physics that we are also studying as a optics. So eye is also a kind of remote sensing equipments. But apart from that, there are lots of instrumentation which came in last 50 to 100 years, you can say, which is very much useful. So specifically in the different department, because it's a kind of multidisciplinary science. It's not a only related to the civil engineering or mechanical engineering or electronics, but it is a multidisciplinary science where obvious the instrumentation which needs the electronics and electrical components and mechanical also. When the data is coming, there is a requirement of IT and computer science itself. When the data is coming, it's useful for the different aspects of civil engineering and other aspects. So it's a multidisciplinary, and it is having a multiple uses also in the industry, because sometimes we are not able to take the data, we are not able to take the data physically. So at that point of time, we required some kind of support from the remote sensing. So there is a as I mentioned, that there is a requirement of energy. As you can understand that, suppose if there is a like eye is the first remote sensing, or natural, you can say natural remote sensing equipments. But if there is a dark situation, so you cannot see any objects. So there are two kind of sensors, which we are right now in the terms of energy, we are defining active or passive energy sensors. In that particular sensor, we can look, or we can imagine all the items which is present over there without the energy of sun, or they are directly reflecting their own energy. So maybe that particular equipment is having their own energy, they are not taking energy from the sun. Because if any equipment is taking energy from the sun, or any sensors which we are using, so that means in the night time it's difficult to realize the items. But right now both type of sensors is available, so we are also able to take the night visions and all those items, so which is going to the obviously to the processing station and then coming in the format of data. These are the basics of the remote sensing. And these are some kind of technical information, you can say that, an energy source or illumination is required to provide the electromagnetic energy to the target. Suppose what we would like to have, so that requires some kind of electromagnetic energy which is reflecting, and we are getting some kind of signatures. And ultimately the data which is coming to use, that is a translation of that particular signature. So that means the raw data is entirely different, and actually what data we are looking, like suppose there is a simple Google map, but if the Google map is there, so that doesn't means it's a data is coming directly like that. So there are multiple data processing is there. So using that multiple data processing, we are getting the process data for the utilization of industry, either it is in terms of traffic updates, either it is in terms of floods and other items. So basically there is a raw data, and then after the data processing, there are some interpretation of those data which we are looking in coming segments. So there are two type of remote sensing what I have mentioned earlier, that one is a passive remote sensing and other is the active remote sensing. In a passive remote sensing system, naturally radiated or reflected energy from Earth's surface feature is measured by different selected spectral bands, where the active remote sensing system supplies its own source of energy. When it is having a own source of energy, then it is an active remote sensing system, and both can be used, depends on the purpose. Like active and passive remote sensing both can be used depending on the purpose, but actually as a data user, we are really just having a basics of these, like what type of sensor it is, either it is a microwave data, either it is a optical data. So there are multiple kind of data, but we have to understood the basic components that suppose if there is a optical data, I'm giving example. Optical means we are looking through the photographies and other things. So what problem we are facing, suppose if I'm going for to analyze the flood, so what will happen? uh, when you are just taking a photography from the above of the cloud, because satellite is above cloud, so what's happening in our optical data, cloud is also a data hindrance, so it is not actually representing the flood what you required actually. So then we have to obviously remove the clouds and other items to analyze the floods. because directly if you suppose if you are having you are sitting above the cloud and you would like to see the land, so you are not able to see it. Same, the equipment is also there. So in that time, if we are using some kind of microwave data based on heat and other sensors, so that may be useful. So the type of remote sensing is utilized where we would like to have those data set. So depends on totally utilization. So just coming to that application part of remote sensing, which is very much interesting because it's having a you can say limitless. If you analyze really, because there are two kind of thing. If you are understanding the things only, okay, this may happen. But if you are using by yourself application of remote sensing in a different kind of aspect, so there are limitless opportunity in that which you can utilize for the different industrial aspects. So I'm just mentioning a few. I'm mentioning some kind of tools also which can be useful, so you can also utilize. Maybe you are also aware about that things. So if just summing it up, what are the uses of remote sensing applications? So just you can mark it. Like here, you can just look that it is in a natural resources like in agricultural, environmental monitoring, coastal monitoring, global warming, disaster response, geosciences, development and construction, conservation and research, defense and intelligence. So it's a limitless, like in every field, now it is touching remote sensing somehow, whether it is a satellite imagery or other remote sensing equipments. In fact, like suppose in offices, we are using a camera, like uh, office camera. So that is also used as a remote sensing equipment to provide a security and other purpose. So like application of remote sensing or uh, applications of remote sensing instrument is getting increased because as we are getting into the era of IT and computation and artificial intelligence, so obviously the data is very much important, and based on data we are all, only doing our interpretation. So, first thing, I'm just coming into the structural health monitoring, which is very much important. So, in a structural health monitoring, you can understand that suppose if there is a, why I have mentioned, because this particular session is for a remote sensing and water resource. So, how it is linked? So, it is linked that suppose if you are making a bridge over river, and you would like to monitor those bridges from a remote sensing equipments, either through the satellites, drones, and other items. So it is possible, and now the this aspect is coming very rigorously. In fact, in a developing country also, developed country, they are doing a structural health monitoring using the remote sensing components, using the lidar data, using the other drones data. And why it is useful? Because somehow, suppose earlier the structural health monitoring, which is happening generally manually, if you are going to the bridges, if you are going to the dam, which are the large water infrastructures, so then only you are just getting, okay, these are the problems. But in the same time, it gets failed because lots of failures is happening due to the change of climatic condition, or you can say the rainfall and other conditions where we are facing a serious issue of life loss as well as property loss. So, what it provide to the industry actually, when you are able to take this kind of projects, suppose if you have taken a X bridge, X number of bridges, and you are saying that you will monitor and then you will provide such kind of information that if there are some issues of safety is there, so you will indicate the concerned authority, so then you can save the life, and in the same time maybe you are able to save the property also. So that's how the remote sensing is used. And now the bridge health monitoring and dam safety is a major issue. And that means major opportunity, you can say. It's not an issue, it's an opportunity for the engineering students or students who is interested to the remote sensing parts. So it is a huge opportunity in the upcoming 20-30 years because it's a relatively new field. So how you have to take, how you have to make a programs, how you have to make a kind of a package for a particular dams or bridge structures. So that is very much useful, and it's also interesting when you are doing this kind of structural health monitoring using this remote sensing instruments. Second, I'm coming to the urbanization and transport. So obviously, in urbanization and transport, because it is also linked with the water resources. When you are doing a urban planning, what's happening that we are generally avoiding the urban hydrology. Generally, earlier it was very general case that we are not taking so care of urban hydrology. So what's happening? Not the immediate results is coming, like immediate consequences are coming. But if we are taking example of Gurgaon, it's a developed almost from 1970 it was developed. But right now the Gurgaon area and other areas are facing a serious waterlogging issues, because in that time the planner is also not, that means the remote sensing is also not so much prompt that you are able to analyze that how the area is behaving in a long perspective of the long time period. But now we are having a data so that you can analyze that these areas are geographically vulnerable to the waterlogging and other things, so that at the stage of planning of roads, of the buildings and other items, we can do the preliminary exercise to place those things. Because earlier what has happened, okay, this area to this area we have to connect, we are drawing a line according to the some topography or contour lines. We are not focusing on that component, that what the remote sensing is providing right now from last 20-30 years. So that is the benefit we are getting from the remote sensing parts. And it is a very you can say a small tools. I'm just showing the in the next part. Suppose I'm showing with the examples also in the natural resource management also, like in a forestry, water resource management, environmental assessment. In fact, hydrology, we are using lots of remote sensing data. Now we are having a GPM data, global precipitation mission, where we are getting a rainfall data itself from the satellite information. So that is also a kind of development which has occurred from last 20-30 years, and we are right now, we are not directly using into the industries, but now industry is also taking it up, as because research is coming very prompt. And in consulting projects also, when you are doing these kind of item for industry peoples, so they are also happy with that. You are coming with the new ideas. So as a like if you are belonging to some of the institution as a faculty, and if you are getting some kind of chance to work in the project where you can utilize those kind of works, so you have to do those works, because that will initiate these kind of interventions and this kind of thought process in the industry. Because earlier I remember that in 2010, when we are doing these kind of studies for industries, at that time we are not having a you can say consulting firm, but we are working as a research scholar in IIT Roorkee. So at that time people are not so much appreciating those things, okay, why you are doing so much of research, what is the benefits. But now those people itself, they are realizing that that is very much essential, and now it is also coming as a guideline. So when you are going like I cannot say that everywhere it is used, but if you are having any chance, just work for a kind of new methods. It's not like okay, these are the conventional methods and we are working like that, because we are not getting some sort of you can say reimbursement over there. So what you will get that in a future, you are able to put your thought process over there. So that is very much important, that when you are doing any small project, in fact. And in agriculture, all of you know that agricultural monitoring, remote sensing having a huge scope in future. Lots of agri startups are coming, which is only into the remote sensing data analysis for the agricultural, and then from the agricultural to the finance, and agricultural to the risk assessment. So in the both component, it is coming. So these kind of activities when you're doing. So what you have to do actually, you have to take a small problems of the your city, and then you try to find out that what are the solutions, because there are the solution. You have to find out your own way. That means, suppose if you have to analyze that what are the agricultural products during particular season, so you can analyze those through. That means why it is getting hampered in a like from 2023 to 24. Is there any issue? So you can also analyze those things from a remote sensing. So both the factors and the results outcome you can analyze, and then you can put that, okay, if this will happen, then that may happen. So based on that, you can analyze the risk over the agricultural products. So that is the one of the important component, because in agriculture, water is one of the important part, which is playing roles like a rainfall data, like a soil moisture data, which is available into the soil. So soil moisture you can also look from a remote sensing or satellite imagery, you can say, and so that you can analyze the farm condition, and you can suggest to multiple companies that how if you are putting some kind of loan to the farmers, so how it is helpful to assess the risk over the like any financial arrangement. So that is a very huge area. And in the same when we are determining the soil moisture from active and passive sensor, which uh, those things are assisting to assess the crop productivity. Ultimately, if the crop productivity is high, so everything, because India, suppose you can understand that India is a agricultural country. So how agricultural matters, you can understand that at least I'm saying that uh, minimum 100 startups is over only the agricultural based remote sensing, where they are analyzing the soil moisture data, where they're analyzing the crop productivity. So these kind of startups are there from last 10 years, at least as per my knowledge, more than 100 startups are there. So why it is there? Because there are the scopes and people are doing those kind of work. So when you are getting some kind of a small opportunity over there, so you try it, and then how to optimize those things, that is the important part, because there is a process. It is not like that only to understand that, but how to work it out, whether it is in a technical manner or whether it is in a commercial manner. So whether it is a tech, maybe sometimes what's happening, some item is technically feasible but commercially not feasible. So obviously we are not doing those items also when we are doing some kind of business activities. But in a teaching, obviously you have to teach to the that means you for your students, you have to make them understand that these are the potential areas where you can grow also, based on their targets, based on their knowledge base. So you can see that these are the some kind of volumetric water content over the water for particular day. So you can see that, suppose this is a data for a particular day, and this soil moisture is available for every particular period, like 7 days, 14 days, depending on the satellite moving. So that kind of data you are not able to take if you are analyzing anything in a very large manner, in a basin wise or watershed wise, because you have to take those data in the field, and then you the field interventions required, you required a earlier you can say cash flow for particular items. But if you are doing with the remote sensing, you are getting a basic information from there. If you'd like to go a finer scale, so you have to go for some testing to conclude, or to make them that how these parameters is varying according to the remote sensing data and according to your field data. So that would only required when you are going a very small scale. But now, in fact, the course scale is also getting finer as the satellites and other items are getting increased by ISRO or other NASA. So the resolution is also getting reduced, because earlier the resolution is very low. Now it is resolution is making high, but sometimes you have to pay the data price also, because if anyone is running a satellites and other things or sensors, So they are taking charges for those data, but ultimately the thing is that you are getting those data as per your requirement. So those data are available and it's very much useful. The next item, what I'm coming with, like if you're locating some new construction and alteration, suppose I have taken this example where I'm living right now in Noida. So I have just taken a simple example. It's a Google map. So you can look into that, how the alteration from like 2000 to 2019, how the changes has happened. So these are like agricultural land, simple agricultural land. Now it is a building construction. So, what is the need of this particular data? If you will say that it's a very simple data, anyone can analyze. But if you are analyzing that, suppose in that area, this area, there is a flooding issue. So you can easily look into that. Okay, these are the roads. There is no roads in 2000 there. So whether those area is blocked by some of the drainage channels. So that might be possible because you look that there are some of the channels and other things is there within a agricultural system. But if we have not taken care of that, so that maybe in your society the water is not coming, but outside the society you are getting a waterlogged area. So that problem, when you are facing those problems, then these kind of imagery, this kind of data is useful. That how much water can come, what are the potential reason from where you can divert those data. So these are the small data set, but when you just thought very carefully, you will find that okay, these data are very much useful on the analytics part. Earlier it was not available, so what we are doing as an engineer, we are just doing some kind of our engineering guess. But now, apart from the engineering guess, we are having some sort of data. In the same diagram, you can see that suppose I am taking this much of area, so now more than 70% of the area is blocked by buildings. So now every like it's a kind of paved surface. So anything in this particular catchment, all the water is accumulating nearby this. So that's how that if you are getting a water on the road, so that's not a surprise. So, but how to use it when you are analyzing those kind of data for your engineering purpose? Same like for a traffic monitoring and parking management, because in a traffic monitoring and parking management also now, when there is a under -1 or -2 parking in the societies, so what they are facing right now at the time of high flood, if the society or any kind of residential area which is lying below the flood plain, like HFLs, so they are getting submerged parking area. You are finding lots of photographs on the internet, specifically for Delhi, Ghaziabad region or Hindon rivers, where there is a parking within that particular area. So you can find out the hotspot areas based on your imagery data analysis. So that is one of the use where the kind of you have to manage the water, but you have to manage the water for traffic. So it's a kind of interlinkage, because all of you. So, I'm just trying to show that everything is linked. If you are just trying to manage remote sensing data and water resource management, so connect is there, but you have to connect that why it is used and what are the uses where you can propose those uses for particular intervention and what benefit you are getting from there. In the same time, like for a military surveillance, all of you know that because lots of satellites are there only for the military surveillance, where we are using those data at the time of any disasters also, or in the time of if there are some military operations and other things which is required as per the government norms, so that the satellite is specifically used for that particular items. Coming to the very important aspects, what we are dealing with the satellite imagery, like floodplain delineation. Suppose if you are working in any river and you would like to find out that how the river is behaving from last 30, 40 years. Because generally the satellite data is available from 1970s when the Landsat came, 71, 72. So based on that area by area, some image qualities, you can at least you can get the data for 30 years minimum. So in that data, when you are planning some projects, so then you can find out that how the river is behaving. And this is the example what we have done for one of our industrial projects for Adani, where there is a requirement to put a intake well uh, near the Ganga River, Ganga bank. So problem is very simple. That means where to place the intake well so that at least you are getting a water, because Ganga, the morphological behavior of Ganga, all of you know, it's a changing very lot. So what we did that when we are doing the analysis, because we have to do multiple things, including this, but we have added this particularly before doing any other items like modeling and other items. That means how much water is coming, what are the labels and other items. But these are the basic study. And I'm mentioning specifically because this work was done in 2016, like 8 or 9 years back when we have started this firm. So in that part, what we found interesting that if you are doing this type of image analysis, so we are finding a long-term river behavior. And after training, because you just look into that in 1977 and 2017, what location we have finally fixed based on other hydraulics and morphology also. But earlier, they are planning these particular items somewhere else where they are not getting actual approval from the departments and Ministry of Environment, because they are saying that okay, river is very fragile and there are some administrative issues also. But uh, ultimately, from this particular floodplain delineation, they got approval because these are the add-ons which we have added as a consultant to the authorities. So they say that because in the 2016, when we have added, those are not common for the consulting project. When there is a critical problems or there are some research problems, so people are using. But right now, these kind of studies very much general. You can look into the any kind of projects. This kind of delineation is very much important. It's a simple kind of, you can say, image analysis using the different indexes like NDWI, water index, or vegetation index. So, but that is useful. You can look into that. Based on that, we have decided the first location, and then we have gone for the detailed survey, then modeling and other items, and we found that these locations are very much stable from last 40 years. So we can propose those location, and now it's like it's a running project. This is the project actually. You have heard about the Adani thermal power plant in Godda. So it's a super critical, and now one unit is running. So intake well is also running well. So that's how when you are planning any kind of project, so that kind of delineation study is very much important. It's look like very simple. You are analyzing the image, but if you are putting this kind of efforts to the projects, so the sustainability of the project will increase. In the same, when we are doing this and we have just analyzed, you can just look from the other angles how we have put that. You just look at the in 1977 and 2017, this river angles. It's totally changed because as I mentioned that Ganga or Brahmaputra, there are multiple channels are there. So how they are behaving, it's very much important when you are doing any kind of projects which requires of water or which is having an impact of water, both. Here there is an intake project, so they require a water. Suppose if you put an intake structure anywhere and the river has left those particular area, so you are not getting a water. So then what will happen? You have to again dredge it out. You have to make a pipes and other things. So other arrangement can be made, but that is also a kind of extra economical affair. You can financial affairs for the company. So that you are avoiding when you are doing such kind of analysis for the projects. The second example, what I have shared here, that is also from our own project. So here actually we have to plan one of the bridge over there. That is it is a tributary of Brahmaputra. Name is Zia Varali. So in that we have to put some kind of embankments and bridge structure. So we have to decide the location of bridge. So when we are deciding the location of bridge, the this delineation is also important. I'm saying why because if you have heard about the last 3 4 bridge failures in specifically in Bihar. So if you analyze deeply, because I have not analyzed before that particular failure, but after failure, I have just found that the location of bridge is not as prompt as, as per an engineer or as per a remote sensing scientist. If anyone can say that that is not a appropriate location, because one thing is that for a bridge you require a connection from X bank to Y bank, but it is also in the same time you have to observe that how the river is behaving, whether that river behavior is suitable for that particular connection is or not. Otherwise you have to shift something, because you are surprised to know that if you heard or if you have read the story of Upper Ganga Canal is it is based out of Ganga, where like it is in Haridwar. All of you know about the Har Ki Pauri, where the water is coming from the Ganga. So when that Upper Ganga Canal is under the formation, at that time that Englishman is Cotley. So what he is doing actually for at least more than 10 years, he has just taken a observation before making any canal. So why the observation is needed? Because from that observation, he's looking after the behavior of the river. But right now, what we are having a luxury, because we don't need to spend a 10 years over there to understand the behavior. So we are having those kind of you can say facility on those kind of technological development what we can utilize. But that if we are deciding any kind of bridge location, any kind of river bank protection, any kind of dam location, so that uh, uh, remote sensing images are very much useful if you are analyzing it properly through the different aspects. So you can understand that how these small things, because you are anyhow coming into this particular item every day, or if you are doing any project, so how these small things can be useful when you are planning then your next assignments. Now just coming to the agricultural monitoring part, how you can like if there is a plot farm area, so from that remote sensing you can find out that how the crops quality or crops area is there, whether there is a crop or whether there is a less productive crop, so that you can analyze. And that is I mentioned that that is a huge scope, although as a company we have not worked any in agricultural monitoring specifically, but we know that there is a huge scope. We are trying to make some kind of decision support system over there. If maybe in a you can say year or two, maybe we are getting into that after attaining the risk or financial risk and other items. So that is a huge scope. And in a remote sensing, the different kind of analysis, because if you are aware about the Landsat data, uh, the Landsat data 9 or Landsat 8 data itself is having 11 bands. So different band is having a different characteristics. So based on your requirement, you have to analyze those characteristics, and then finally you have to put your proposal to the industries so that they are accepting those items as per their requirement. Next, I'm coming to the rainfall measurements. And as I mentioned that there is a GPM. So in GPM, it's a global precipitation mission where India is also a partner of this particular mission. And what we are getting actually, we are getting a half hourly rainfall data. So you can understand that if what are the uses of half hourly rainfall data. Earlier, what's happened that suppose if you required some kind of rainfall data, so you must have to go to the IMDs because IMD is a custodian of rainfall data, either it is a daily or sub-daily data. But when you are planning any particular project, at the first level, you are not getting those data very easily. So what we are doing that generally we are just assuming something. So in my point of view, when you are assuming something, it is better to take the GPM data, which is available at least after there is a TRMM data earlier, tropical rain missions. Now they are telling this particular as a GPM mission, where we are getting at least 25 years of data. So in that, what you can do if you are having a rainfall, so that means you are able to analyze the hydrology of that area. If you are having a rainfall, you are able to design a drains of particular area. What you are minimizing if you are using those rainfall data. Maybe this rainfall data is not 100% accurate. I'm not saying that, but at least you are having a good data sets, having a fair values. So based on that, if you are designing anything at the early stage, what if you are designing anything based on your guess value, so it is better than that. You can utilize those rainfall measurement data for any particular area, and you can use for any kind of drainage design, any kind of other infrastructure design, and you can also validate in the same time. Suppose if you are having a automatic weather stations, if you are having a rainfall, other rainfall data like uh, earlier what we are having at different weather station to collect the rainfall data. So you can validate also those things so that it is getting refined. In fact, when we are using those data in 2010 and now when we are using these data, so that means there is a difference because they are also refining their algorithm. They are getting the data set original. In original, they are getting some satellite of information, making an algorithm, and finally providing a data to use for a public or for a industry or for a research purpose, you can say. So, and obviously for to manage the disasters also, these data are very much useful. How the disasters are coming, tropical cyclones and every item. So you can look into in a, you can say, near real time manner. So that you can understand that how this remote sensing has uh, get changed the whole information system which you would like to use for a water source management either directly or indirectly. Because when cyclone is coming, there is a chance of heavy rainfall also. And in a heavy rainfall condition, waterlogged areas, if you are a city manager, so you have to plan for your city. That means this much amount of water is coming. So what will happen? So ultimately, uh, what I would like to say that these data is having uses, but until and unless you are not able to use by yourself, that means how to uh, take those data for your analysis. So that may not be useful because for the visibility, you will get a thousand of presentations over the internet, and now there is a you can say it's a era of chat GPT. So you are getting all the informations on over there, but you have to take a small assignments, and then you have to take that how these data you can extract those data, analyze those data. Then it is useful only. Maybe I will say if I am having a time, I will show at least for a rainfall data. You can look into that how you can get that. If I'm having those, I don't know. I'm having a time. Okay. So if I will get the time, I will show for a 5-10 minutes. So then you can go to your home and you can analyze that. Okay, these data are available, and the data are huge. So it's not like then coming to the surface elevation with the SRTM because all of you must be aware about that. If you are using anyhow some kind of these data. So SRTM is what this is the mission for a topographical data, like it's a geographical data, how the geography, how the terrain is there. So that is a too much useful for a hydrological purpose. It is useful for alignment of roads. It is useful for other water infrastructures development, locations developments. So these data are very much useful, and these data, SRTM data, is freely available from the USGS. It's in public domain, so you can utilize over there. All only the thing is that this data is a little bit coarse, but for a watershed area, it's very much useful, because sometimes people are only saying that when people don't want to use, so they will say that okay, resolution is very bad. But as a starting point, I am saying that if you are having at a watershed level this resolution, at least you are having a good information over there. So what remote sensing did actually, they have provided a multiple information. It's a right and wrong. It will come when you are doing very much finer details over there. So then you have to go for a different kind of surveys or a collection of data. So that might be possible. But for a preliminary, in fact, up to the detailed project report, you can believe on those kind of data. There is no issue over there. And as I mentioned that since for a river morphometric attributes, it is very much useful. So this is a kind of study. This is also done by a firm. So in that study, actually, we have to analyze the impact of Baras on the Ganga, because in 2016-17 there is a hot issue that due to the Farakka Baras there is a flooding in Patna. So that we have to look into that, whether that impact is there or not, and if the impact is there, what is the behavior change in the Ganga River before Brahmaputra in last 30, 40 years. So that analysis we did that, and we found that morphologically it is changing, because it's a Ganga. Ganga is in a deltaic. Geologically, it will change the courses in 30, 40, or 50 years, because it's Ganga is having their floodplain, and Ganga is trying to move within their floodplain. Sometimes it is breaking also, because the floodplain of Ganga is still, it's very much defined. Because if you are doing same thing for a Kosi River in Bihar, so you find that the floodplain of Kosi is more than 100 kilometers. So the behavior of is still very stable. So it is flowing within their flood zones. But the problem is that if we are going within the flood zone of Ganga, so obviously we are facing issues. So we have analyzed those for the Bihar governments, and we have submitted the detailed project. That means why it is happening, and what actually you can do that if you would like to stabilize those kind of channels. And we have also done the detailed, like using the bridge morphology, how it changes. Suppose if you are putting any bridge over the river, so what we are doing, that we are making some structural intervention. So obviously there is a change in morphology. So this study we did, and we have published a research paper over there, natural hazards also, where we are trying to simply find out that whether the if impact of bridge is there or not. So we found that it is a very interesting study. You can just look into that. Uh, there is an impact of bridge, because before construction of bridge, what the sinuosity index or what the morphological parameter says, that it has get increased at least for a 4 to 5 kilometers upstream and downstream, because there is a formation of guide burns and other items. Although these studies impact sometimes reverse in for the construction projects, but as a researcher or as a consultant, we have to look into those aspects, that how the bridge is impacting and how to mitigate. So this study is very, that means it is well taken by NHIDCL later, and they have changed some of their guidelines also. So that kind of studies can be performed also based on a remote sensing studies. So that is very much interesting. Next, coming to the groundwater status, because we are talking about the water management. So from the remote sensing, you can also analyze the groundwater. That is a surprising also because uh, if as a layman, if you can understand that how we can analyze the groundwater using a satellite without touching it. So this is actually this is a GRACE satellite, and GRACE satellite it is based out of gravity system. So that means it is analyzing groundwater using a gravity principle. Suppose if there is a column where it is filled with completely soil, so it's a and you are throwing one stone in that. So obviously, if there is a soil, it will not go through the gravity because the soil will resist over there. But in the same time, if it is a water column, so it will go fast. So based on those kind of you can say general physics, it can be analyzed, and now it is very much useful tool which can be used for a groundwater vulnerability and other items, which is generally not available. The data, raw data, is not available to analysis to analyze those things. So it is very useful tool, and right now you can look into the. In fact, in the research background, also lots of people are publishing paper on that base, how the impact of the urbanization is happening, how the impact of other interventions is happening. So these data are very much useful, and these data can also be from the look from the NASA website where you can get those kind of data for particular resolution. Next, coming to the land use land cover analysis, which is one of the important aspects when we are analyzing any water set, because land use land cover decides the hydrology of that particular area. Suppose if any area is having a 100 hectare, and in 100 hectare if the 70% is urbanized, non-urbanized, and 30% is urbanized, and if the items reversed, so what will happen that the generation of water will be more. If the rainfall condition is same, so the runoff will be more. So land use land cover analysis will be used to uh, do any kind of rainfall runoff modeling. So that is the useful component, or you can say ingredients, when you are doing a rainfall runoff analysis. So land use land cover can be done from the remote sensing data. Earlier, it was done through the physical survey where we are going and we just measuring that okay, 30% of the area is urbanized, 20 is paved, 20 is agricultural area. But now the technology is available. You can do the land use land cover analysis, and based on that land use land cover you can put some parameters for particular land use land cover, and then you can do a detailed hydrology over there. So this is the land use land cover where you can differentiate that what is the grassland, urban lands, and other lands. So these land use land cover analysis basically you can do from optical data. Optical data in the sense you can say if in a public domain it's a Landsat data, you can do land use land cover, or there is a Sentinel data also which is also available through the European Satellite Agency ESA. So in a land use land cover there are two types. You can do it is in a supervised manner, in unsupervised manner. In a supervised manner you have to identify like pixels by pixel whether it is this is agricultural land, urban land, and then you have to classify. In unsupervised there are some indexes are there, already established indexes by the researchers, which you can use, like one of the you can famous index you can say NDVI. So NDVI, from NDVI you can easily identify the vegetated area, non-vegetated area. Similarly, NDWI, normalized difference water index, from where you can differentiate water area, non-water area. So there are multiple indexes like NDBI, building index. There are multiple index which can be used for the different land use land cover as per your utility. You can do that. So when you are doing a land use land cover analysis, so you can just compare also that how can for like 1985 there is a different area like forest 20%. When it is getting in 1995, it's almost similar, but in 2005 and 15, it is getting decreased by 2%. So that the impact study can be done. So you can understand that how it is useful when you are doing any kind of detailed planning for any small area or large area. It's not only it's for only the water set. If you are doing for a small towns also, it is also useful. Suppose if you are a town planner, if you are in fact, if you are doing for a simple village, I'm telling one of the simple example of like this kind of image analysis for public purpose. Actually, in last year in Bihar, there is a huge flood, but people are not get compensated through the department. Then one of the you can say Mukhia, they said that can I get the past data from last September to December so that we will present those data to the authority. Our villages gets flooded, so can the people can get the compensation. We did this as a, like a charity work because we know that they may get, they may not get because there are some administrative reasons, but they have received those amount at least more than 25 villagers has received those amount where their agricultural lands get submerged, and we have analyzed just through the imagery analysis. So that kind of study also boosts that the usefulness of the technology. In fact, one of the interesting thing is which is coming like depth of the water bodies. Suppose if there is a river and if you'd like to find out the depth of that particular river, but right now, as per as my understanding, depth of the water body, if it is flowing, it's not so easy to find out from the optical images. If until and unless you are having a blue lidar, so you are not getting underwater depth. But for a you can say there are some algorithms there. If you are using a Landsat 9 data for a reservoir, like if it is a still water, so you can get at least 60 to 70% of information over there, up to the 20 to 30 meter of the depth of the reservoir. So that is a kind of good set of data where you are where there is no data is available. So, but it is still hold good for the still water system, not for a moving water system like a river. Still, there is no clear-cut algorithms there, but we are trying to do some of the survey and validation so that maybe in future we are getting those kind of algorithm also to get the directly flowing water depth. So what will happen if it is there from a remote sensing? So then the survey, what the bathymetric survey which is happening physically right now from the ADCP or other current profiler, so this will diminish and you are getting a more higher temporal resolution because when you are doing a survey or bathymetric survey, it is doing for a 10 years or 15 years. So, and river is changing their behavior every day or every 10 days or every 5 days. So when these kind of technology or algorithm will be developed in future, and I'm sure that because in 2024 itself there is a SWOT mission where they are having a clear-cut target to get the depth of water bodies, including some of the field information also. So maybe uh, at the end of 2025 or 26, you are getting those kind of information also from the remote sensing technology. So we can also analyze that what kind of channel it is, whether it is a stagnated channel, it is a moving channel, uh, using the remote sensing. So that is a one kind of if you are doing some ecological or environmental analysis. So that is also useful. So overall, you can look at how much utilization of remote sensing uh, technology is there. But first, you have to set your target. That means what you would like to have. Take a small assignments and then do the work. Otherwise, at the early stage, I mentioned that there is a limitless. At least if you study for 2 years, you understand that okay, you know only 0.001% of remote sensing data and analytics, and then final conclusion. So it's not surprising that it's a very huge area. And apart from what we have, we discussed that there is a use of detection of landslides also zones. So these are the landslide zones which is identified using the remote sensing, or you can say imagery, satellite imagery. So this can be also useful because suppose if there is a huge flood in the river, and at that time if there is a landslide, so what are the chances there? There is a kind of, if there is a some kind of infrastructure is there, so there may be some problem, because then the flow will become a non-Newtonian. If the suppose there is a simple water flowing, and if there is a landslide at the time of rainfall, higher rainfall, so you can detect a landslides and you can just warn the authority, okay, this may happen. So the detection of landslides also is possible through the remote sensing. And these are some forest managements and ecological studies. I'm not going into the detail because I would like to discuss the rainfall data specifically, which is very much useful, and you can just look into as a small assignments also. So right now we are also using infrastructure management, as I mentioned that we are using a cameras and all those things. Those are also component of remote sensing. It's not only that, only the satellite imagery what we are using, but uses of satellite imagery is on higher side, you can say, specifically in water source management. We can also do the air quality through the remote sensing. We are also trying to get, there are some algorithm is there, but ISRO is also planning to set up a satellite specifically for the quality through the remote sensing. So that if that will come, right now there is an algorithm, but now based on those algorithms they are trying to validate those data from the field, and at least a basic water quality parameter you can measure from the remote sensing. So that is one of the important breakthrough. Maybe in 2026 or 27, they are planning to have a satellite over there. After they are getting a good algorithm for the sensors, particular sensor. So this will also get a good input to the uh, engineering students or engineering practitioners. These are the environmental stress. I'm just skipping that. Next, coming to the drainage density, because drainage density is one of the important parameter when we are planning any drainage structures over there. Suppose if there is a factory area or any area where you are trying to plan any industry. So based on that drainage density, you have to map that your drains, and ultimately those drainage density can be created using your topographical model. So these data are useful when you are having uh, actual contour data over there. So when you are planning a project, so at earlier stage you can utilize a coarse resolution data like SRTM. In fact, right now, apart from the SRTM, there is a Cartosat data also, which is a ISRO based data. So that you can also utilize having a 30 meter. In fact, now they are giving a 5 meter, 2.5 meter resolution also to map for a finer area. You can also analyze the soil characteristics over there for from the satellite imagery, which is very much important parameter for a crop productivity and other items. In from the remote sensing, you can also measure ocean wind also, so that if there is a wind power in ocean or ocean area, so that can be analyzed and planned over there based on the remote sensing data. Otherwise, what you have to do, you have to go do some instrumentation. But for a preliminary analysis, it is very much useful tool. And in fact, at the up to the level where you can just go for a proper project planning. A solar energy assessment using remote sensing. So that is one of the component also, because right now the solar energy is also getting boost by the industry. So that can be also assessed for a particular area where you're trying to put your plants and other things. So that is one kind of studies which can be done. Why I put this particular, because we are talking right now about the remote sensing, specifically the satellite imageries and other data from the satellite or drone data. These are also kind of remote sensing equipment. Like this is the laboratory equipment where we are taking a velocity of the channel without touching to the water. So this instrument named as a LDV. This is a laser Doppler velocimeter. So it's based on a principle of light. So we are just placing a laser light, and based on that there is a particle movement over there from a x fringe to y fringe. Based on that movement they are tracking the length and the time, counting the time, and finally estimating the velocity over there. So ultimate output is velocity, but it is the equipment also which is termed as a remote sensing, because we are not touching a water but we are measuring a velocity over there. So these kind of instrument is also termed as a, so that I have mentioned that earlier in that remote sensing is not only that we are using a satellite imagery, but most of the uses in water resource management. But this is a kind of equipment also which is used in a laboratory, and also in the field practices. Small LDV is also coming, which you can use in a field practices also. So this is out from my presentation. I just like quickly wrap up if you are having some questions. Otherwise, I will go to just for an info for 5 to 10 minutes. Then I will wrap up. If anyone is having a question,
Any question? So there are some questions we can see in the chat box.
okay. Okay, there are questions. Okay, there's no questions. One people have introduced link. Someone please send. Yeah, the question from Karthik is that during the cyclone, we have a cloud cover affect the satellite image and reduce the accuracy. In such cases, what can we do for a better results? Obvious, when there is a cloud cover, there is a algorithm also to remove the cloud cover. Otherwise, at the time of cloud cover, if you'd like to have uh, microwave data, so you can utilize those kind of data which is based on, actually not based on a optical principle, it is based on a microwave or heat wave principle. So that can be utilized. And first, one thing I'm just trying to say that uh, if you are a starter in that particular area, so don't try to only compare the accuracy. Accuracy come later. First you have to work it out whether it is possible or not. So, as you mentioned that accuracy can be improved when you are using non-optical data. In optical also there are multiple algorithms to remove the cloud, but there are some inaccuracies also there when algorithm is also confused with the some kind of, you can say, if there is a snow and there is a, because it is also based on a principle of colors. So totally it's depend on the how your algorithm is mentioned. Otherwise, you can use a microwave data. What are the limitations and challenges? Track glacier melt and its impact on water resources. So glacier melt, you can look obviously from a land use land cover. You can identify that how the glacier melt is right now and 10 years before or 20 years. And obviously its impact on water resources you can analyze from if you are having some kind of water availability data. Otherwise, you have to go for some models, because water availability right now, the water availability, like quantification of water, is not directly with this particular any imageries or any imagery solution. Right now, one SWOT mission is there with the NASA, which they have started providing some kind of data, but still the validation is going on. Then it is useful directly that how the glacier melt is impacting your water sources. Which one is the better technique for LULC, supervised or unsupervised? I'm saying that supervised is better technique, but it will take lots of time because you must have an idea about that particular terrain. But if you are having no idea about the terrain, the unsupervised is better. If you know the area, then the supervised is better. But if you don't know any area, it's a totally unknown area. So unsupervised is also good because it's a tested. All the parameters like NDVI, NDWI is already tested. So it is not like that it will not provide the features over there. Can avalanches can be predicted using GS technology? Yes, it can be predicted, but under some limitations because avalanches is like it's a kind of landslide with the glaciers. So it can be, you cannot directly say it cannot be predicted, but you can identify the hotspot zones because prediction is different because there are multiple trigger parameters. Suppose if we are able to link those trigger parameter, then it can be predicted. But the prediction is not a right term. You can say that you can identify the hotspots. Okay, these areas are prone to the avalanches based on the different analysis. Next is can groundwater level be? Again, the question is like accurately. I cannot say it's so much of accurate, but at the basin level, it's good. Can you predict adverse climate to the farmers? If so, how? Can you can we do study with the UAV platform? Yes. There is a question from a UAV platform. Yes, we can do that from a UAV because UAV is also like satellite is also an unmanned vehicle. Only the thing is that satellite is it is at some higher height. UAV or drones, what we are doing that sensors are similar because what sensors like lidars and other things which are sensors which we are using in our satellites also and which we are using in our drone system also. In drone system, we are getting a high resolution, but the time of pass is higher. From a satellite, you can get a data for all India in a 1 day or 2 day, but for a drone data you cannot get. So there is a limitations of times, economics, and other items are also there. Can we predict adverse climatic conditions to the farmers? Actually, again, I say that it's not all about the prediction. Satellite imagery, what we are doing that we are first trying to establish an algorithm that what are the impacts. Prediction will come into the future if the algorithm is established. Because right now we are 30 to 40 years old in a GIS technology. But climate is a very long term context. It is not like a 30, 40 years. It's a more than 1,000 years or 10,000 years climatic conditions. Because we are generally confused with weather and climates. So climate is a very long term perspective. So right now we are not having so much of data set to predict a climatic condition exactly to the farmers at the scales what you're talking about. But we are getting some kind of good information over there so that the risk can be minimized. Can the broad level that is accurately? I have already answered Hemanta's question that accuracy first you have to start that. Accuracy is like right now the grace data is so much of finer, but now they are trying to get a finer data also as they are getting a ground information. How to know, Hemant Kumar, how to know previous data of remote sensing? There are lots of websites. Like there are lots of like if you are just going to the Bhuvan, Bhuvan is a Indian website where you are getting the data from a ISRO. So some data is in public domain, some data you have to purchase. Apart from the Bhuvan, you can go to the NASA where you are getting some kind of previous data. How many training samples should be sampled for one class of LULC? At least five in one area. Because there are some, suppose if there is agricultural area and maybe same, that means agricultural area is having a different color bands depending on the type of crops and other things, but those are the agricultural area. So at least minimum 4 to 5 is required. I think question has ended, so I have a 5 minutes more, 5 to 10 minutes. So okay, I will show one of the rainfall data if you'd like to have. Otherwise, it's not necessary. But I would like to show that if we note it down if you'd like to have. This is actually going, you can say, a live demo. This is a very useful platform, you can say, where you are getting a varieties of data, what you would like to have in a different formats also. So right now, this is the you can say select a reason because right now it's for whole world. So I'm just taking some of the examples because making some random examples. I'm taking this particular area because for time purpose. Otherwise, it will take more than 1 day to run the model over here. So I would like to find out the precipitation data of global precipitation mission. So you just search a global precipitation mission and you look at what kind of data is available. So like daily mean precipitation data from 1998 to 22 January 2025. So you can understand that you are getting the data from last to last day at least only. Like it's a near real time data. So suppose I'm just telling this data and I'm just not giving all the time period because you have to provide the dates. So suppose I'm giving you some dates like in 2024 on 1st January to 1st January 2025. And I'm just trying to find out the area average because there are lots of statistical option also where you can select your data based on your requirement. And I'm just plotting those data. It's very interesting. If you just go inside that, you find that it's an ocean. You are getting lots of data set, not only the precipitation, you're getting a soil moistures, you're getting other items. So it's already mentioned that the bridge between data and science. So if you are interested in remote sensing, you can find out. So you just look that how the millimeter per day data is coming. So it's a rainfall pattern over a particular area. It's a area average, but you are getting the information. So that is important. If you are getting no information over there, and if you are getting information for any particular things, so that's only I would like to say over the graph. You can just go to this particular website, log in. It's a kind of what time you are giving to the social platforms. You can give to these kind of platforms, and you are getting plenty of informations, plenty of analysis technique, plenty of things that you have to also develop your skills also. So thank you very much for your participation.
Thank you, sir.
I think it may be useful for you. You can find it out.
So on the behalf of organizing team, once again, I take this privilege to thank you from the bottom of my heart, and it was so wonderful session. Actually, sir, this was the only session in which I can see so many questions were put up in the chat box. So I guess it was one of the interactive session so far, and the session was so enriching. And definitely we are looking for more session in coming future. So thank you once again, sir. Thank you.
Thank you very much, all.
Thank you, sir. Good night.
Good night.